Let's talk about the ground beneath our feet. I mean, what is it really? For most of us, it's just something to walk on, something to build on. But what if I told you it's actually one of the most complex, most critical engines driving our entire planet? So today, we're going to dig in, literally, and uncover the secrets of soil.
Most of us have a simple word for it: dirt. It's something you wash off your hands, something that feels kind of lifeless and inert. But, as we're about to see, that could not be further from the truth.
Because the reality, it's way more incredible. Soil isn't just dirt. It's a living, breathing ecosystem. And it has some of the most important jobs on Earth. It grows our food, it purifies our water, and yeah, it even helps regulate our climate. It's kind of like the silent partner that makes all life on Earth possible. All right, let's start right there with that foundation. What is it that makes this living system so absolutely fundamental to our survival? Okay, so healthy soil gives us what scientists call ecosystem services. And these are basically massive planet-scale jobs. It pulls enormous amounts of carbon out of the atmosphere, which helps stabilize our climate. It acts like a giant natural filter, purifying the water we drink. And of course, it's the very starting point for pretty much all the food we eat and the materials we use. The bottom line is simple, really. You just can't have a healthy planet without healthy soil.
So, how in the world does a handful of dirt pull all of this off? Well, the secret is all in its architecture. We need to zoom way in and see exactly how it's built. It really all starts with these things called soil aggregates. The best way to think of these is as the fundamental building blocks of the soil. They aren't just loose particles, they're these amazing little clusters of sand, silt, clay, and organic matter, all bound together into tiny, stable little units. And get this, these aggregates don't just happen by magic. They're actually built through this incredible partnership. On the biological side, you've got microbes creating these sticky glues, while plant roots act like tiny nets, weaving everything together. At the exact same time, chemistry and physics are hard at work, with charged particles bridging the bits of clay, and even the simple cycles of rain and sun pressing everything into shape. So when all these little aggregates stack together, they don't just form a solid block. No way. They create this incredible, intricate network of pores and channels. It's like a hidden city of pathways for air, for water, for roots, and for billions of microorganisms. This structure, this is everything. And honestly, this is the perfect way to picture the difference. Healthy soil with that great structure is just like a sponge. Water soaks in easily and gets held in all those little pores, ready for plants when they need it. But soil with poor structure, it's basically a brick. Water just can't get in. It runs right off the surface, and guess what? It takes precious topsoil with it, or it hits a compacted layer and just sits there, useless. So what's the magic ingredient? The secret sauce that builds that sponge? It's something called soil organic matter. This amazing mix of decomposing plants, microbes, and all kinds of other life is the glue, the master binder that creates and stabilizes those absolutely vital aggregates. And that brings us right into the modern world, and specifically to farming. Because our agricultural practices, well, they act as a double-edged sword. They hold the power to either build this incredible living structure or systematically tear it right down. Let's take tillage, plowing. Conventional tillage, where you flip the soil completely over, might look good for a season, but its long-term impact is just destructive. It shatters those precious aggregates, it releases stored carbon straight into the atmosphere, and it compacts the soil into that brick we were just talking about. But the alternative, conservation tillage, it's all about minimizing that disturbance, protecting the soil's natural, sponge-like structure. But there is some good news on this front. The data shows a pretty significant shift in how things are done. For example, in Australia, about 68% of farms now practice some form of reduced tillage, which is a huge step towards more sustainable land management. Okay, let's switch gears to another huge piece of the puzzle: nitrogen fertilizer. Now, it's essential for feeding a growing world, but the process is, well, it's shockingly inefficient. On average, crops only end up using about 20 to 40% of the nitrogen we apply. That means the vast majority, up to 80%, is just lost, gone. It vanishes into the environment. So that begs a massive question with some really serious environmental consequences. If the plants aren't using it, where is all that extra nitrogen going?
Turns out it escapes in 3 main ways. Some of it just turns into ammonia gas and vanishes into the air. You can think of it like evaporation. That's called volatilization. Then in soggy, waterlogged soils, certain microbes actually convert the nitrogen back into a gas, which then escapes into the atmosphere. That's denitrification. And finally, a huge amount of it just gets washed away by rain, leaching out of the soil and ending up in our rivers and groundwater. And that second pathway, denitrification, it has a really nasty side effect. One of the gases it produces is nitrous oxide. And as a greenhouse gas, nitrous oxide is almost 300 times more powerful at trapping heat than carbon dioxide. I mean, just let that sink in for a second. 300 times. A big chunk of our lost fertilizer is becoming a super potent greenhouse gas. Okay, so yeah, we've laid out some pretty big problems. But the great thing is, the science doesn't just diagnose the issue. It also gives us a clear path forward. This is all about building a better footprint by working smarter with our soil. And really, all the solutions are connected. First, you've got to actively manage and build that crucial soil organic matter. From there, we can get so much smarter with our nitrogen, applying it precisely when and where it's needed, even using special inhibitors that slow down those escape pathways. And finally, managing basic soil chemistry, like its pH level, just makes sure the whole living system can function at its best. And the payoff here? Oh, it's huge. It's a genuine win-win-win for everyone involved. Farmers get higher crop yields and become more profitable because they stop paying for fertilizer that just disappears. We all get cleaner rivers and groundwater, and the entire planet benefits from a dramatic reduction in greenhouse gas emissions. When you really boil it all down, it comes to this fundamental shift in how we see things. The future of sustainable agriculture isn't about overpowering nature. It's about understanding and working with the soil's incredibly complex and powerful natural systems. And that leaves us with one final big question. We've seen that soil is the literal foundation of our food, our climate, and our clean water. So the question for all of us is, if soil is the foundation, what are we going to choose to build on it?